Welcome to this comprehensive tutorial on enhancing component performance in React using React.memo. In the fast-evolving world of web development, performance optimization has become crucial. As applications grow more complex, ensuring they remain fast and responsive is essential. Today, we'll dive into React.memo, a tool that can help you achieve this by preventing unnecessary component re-renders. Whether you're working on a data-intensive application like a real-time dashboard or simply want to optimize your existing React app, understanding React.memo will provide you with the skills to enhance your application's performance effectively. Let's first explore the theory behind React.memo and its role in performance optimization. React.memo is a higher-order component that optimizes functional components by memoizing them. This means it stores a snapshot of the component's rendered output and reuses it if the component's inputs or props haven't changed. By doing this, React.memo prevents the component from re-rendering unnecessarily, reducing computational overhead. Imagine React.memo as a smart assistant that checks if anything has changed before doing extra work. If everything's the same, it saves time and resources. This concept is especially useful in scenarios where a component frequently receives the same props, or when it's part of a large list, such as in financial applications displaying live stock prices. However, React Memo performs a shallow comparison, meaning it only checks the top-level properties of props. This can lead to bugs if you assume it handles nested objects automatically. It's crucial to understand when and how to apply React Memo effectively, balancing its use with your application's specific needs. Now, let's look at a practical example to see how React.memo works in action. Consider a simple React application that includes a counter component. In this example, the counter component is wrapped with React.memo to prevent unnecessary re-renders when unrelated state changes occur. In our app.js file, we have a state for the counter and another for toggling a Boolean value. The counter component only re-renders when the count changes, thanks to React.memo. This setup demonstrates how React.memo can optimize performance by limiting re-renders to only when necessary. Let's walk through a demonstration of this React.memo implementation. Initially, when you load the application, you'll see the title, React.memo Performance Demo, and a counter displaying 0. When you click the increment button, the counter increases by 1, and you'll notice that the counter component re-renders, as indicated by a console log message. However, if you click the Toggle Other State button, which changes an unrelated state, the counter component does not re-render. This behavior highlights how React.memo effectively prevents unnecessary re-renders, enhancing performance. The demo also ensures no errors occur during these interactions, confirming the stability and efficiency of using React.memo in this context. To wrap up, we've explored how React.memo can significantly enhance component performance by preventing unnecessary re-renders in React applications. By understanding and applying React.memo thoughtfully, you can optimize your apps, making them more efficient and responsive. Remember, while React.memo offers powerful benefits, it's essential to understand its limitations and use it judiciously. As you continue developing your React skills, consider integrating React.memo with other performance optimization techniques like lazy loading and code splitting. Thank you for joining this tutorial, and I encourage you to experiment with React.memo in your projects to experience its impact firsthand. Happy coding, and see you in the next video.